So very good evening, guys. So let's start with today's topic. So yesterday we have discussed regarding your traditional network. Today we'll be going to understand what is the limitations of your traditional network, what is your underlay, what is your overlay, and cryptography. Okay. So today we'll be winding up with your fundamental topics. So next session onward, we can directly jump into the SD-WAN topics. But whatever topics so far what we covered, this will be very vital and important for your understanding of this core technology. Now, so let's discuss what is the traditional network. Can you guys give me the idea about what is the traditional network? What we discussed in the last session? Yes, anyone?
Will have its own control plane, data plane, and management.
Not management of the data plane. How data flow in traditional networks? No, see, you are having a device. Now consider you are having a router. Okay. Now this router is having three planes. Management plane to connect to the device, configure the device. How you configure the device? Without connecting device with over CLI, GUI, Telnet, SSH, can you configure the devices? No. To interact with device, you need to connect to the device. So you need what? Management plane. Currently, this is out of context in terms of SD-WAN, because we will be not going to discuss this, because without initial configuration or skinny configuration, you will be not able to pass any control information, like any information to the controller. In order to communicate any centralized device, basic configuration you need to do at the devices, right? It's not like you put devices out of box and directly they will start communicating with the centralized device. No, some configuration need to be done, right? So for that, you need to connect to the device. So you need management plane for this. Then secondly, we'll discuss your control plane and the data plane. Now control plane where you will be going to configure the intelligent. Correct? Intelligent configuration. Then data plane where your data goes in and goes out. Can you remove this factor? Can we remove this factor? Data plane. Can we pass your data plane directly to the controller? No. Data plane you can't pass anywhere. That is what you are going to receive, and that's what you need to decide how you'll be going to forward from any particular interface. Correct? So data plane you cannot transfer to controller. So what will be passing? Control plane. Correct. So then what is the limitation of your traditional network? So we'll go forward and we'll discuss then what is your underlay, what is your overlay, and cryptography. So tell me first. Limitations of your traditional networks are what? We understood we will be going to connect to the network via different ways. How many ways you will be going to connect to the network? You can use VPN connect. You can have ADLs connect, which is asymmetric digital subscriber line. Correct? You will be having Ethernet first mile, Ethernet based communication. We'll discuss what it is. Then fiber lease line, and this VPN to VPN connection. This many ways you can connect to the device, right? Yes. Means with your ISP, what relation you can have?
Service provider.
Yes, service provider. What all service provider will serve you?
Security.
Not at all providing the security. Service provider can give you the service as a broadband. They will be offering what? A bandwidth. You get a connection for what? 50 Mbps, 100 Mbps, 200 Mbps. Bandwidth, broadband, they will be going to offer a particular band, a bandwidth, a range they can offer you. So you can purchase the bandwidth along with the IP. Public IP identity, obviously, they will be going to provide. Correct? In old traditional network, we used to have asymmetric digital subscriber line. Subscriber line, when we discuss frame relay networks, then also we used to have what? Circuits, dedicated circuit from one branch to another branch in hub and spoke infrastructure. So you'll be having what? Dedicated lines. Similar way, you will be having dedicated fiber lines, because fiber line cannot be shared. Correct? Can you share the fiber line? Let's say I'm using the same line, you also use the same line. No, right? We want dedicated line from one branch to the another branch. So you'll be going to have one dedicated fiber line. So these all are way you are actually going to connect over the internet. So to your ISP. So if it is MPLS means your ISP don't have any information. Means your internal core is BGP free. You are switching your packet based on labels, and ISP will be not looking into the right. Only P router will be having information, not internal router will be having information. Correct. So these many ways you can actually form a network with ISP. But again, how your packet move from your one branch to the head office, but it is not allowed to serve a internet. Have you observed that like many people are working in organization, right? When organization give you a specific device, you can't open anything else which is not permitted. Why? First of all, you need to connect to the VPN, which is site-to-site VPN. Correct? Which is that VPN? Site-to-site? Types of VPN.
It's
What
client
it
to
is?
site VPN. Client to site.
Remote access.
Remote access.
DM VPN. Type of VPN. How many types of VPN are available in the market? Which two?
Two.
Remote and site to site. Remote means
Office to employee.
and then site to site. LAN to LAN, consider it's a like branch to branch. So when you are saying a VPN, when we say VPN, then consider now. VPN is having how many types? Site to site. It can have multiple types also. But mainly we categorize in remote and site to site. Site to site means you will be going to form a tunnel between your one branch to another branch. So once you tunnel set, not daily basis, you have to configure the tunnel. Once it is set, whole traffic is now communicating to each other. Remote. Now people are working from home. And everybody is not direct, like 24/7, not everybody is connected to the VPNs. So number of employees will be going to form a separate tunnel with the site. Means your offices. So everybody will be going to form a VPN inner. So how this VPN will work? You are using what? Application, which is provided by company. Company's VPN you will be using, right? Let's say company name is something. Let's call NHVPN. Never hang VPN. Huh? So this is NH application will be installed in your system. What this application is having? A mechanism to establish tunnel from your system to company system. Over what? Over internet. Now who is this internet is? ISP means local internet, normal common internet. Correct? Untrusted network. Now over untrusted network, how your traffic is going from your laptop to the company safely. VPN, asking question just to clarify your doubts only. So how much you guys are knowing, you have to give me those inputs, then I can correct your gaps, right? If I start directly delivering the content, will you able to follow how the checks, where the gaps are? Question answer session is only to fill out those gaps. We are not looking for correct answer. We are looking for gaps. If your gap is filled, then you can move forward. So fundamental will be strong. Correct. Because many of you not completed your advanced routing. Correct. Now, so when you will be forming this tunnel from your source to the destination, you will be going over your ISP. Now, for this, you need to understand a couple of things. First thing, what is VPN? And second thing, how to provide security to the VPN. Means what is a VPN then? VPN is not secured. What is a VPN? What you will be telling me? VPN is a secured. Nobody understand what data is going into the VPN. ISP don't understand the traffic what you are carrying. Correct? That is what VPN you think, right? Not 100% true. Partially. Terms and conditions applied. How? See here. So I'll cover slightly. I'm not going to go for any configuration part, only the theoretical part. Any information you want to know, ask me. If any doubt you are having, ask me. And if you don't want anything, inform me. So let me just get paint here. Transport. Yes, Anthony, what you are asking? Transport is answer you are giving, or you're asking what is the transport? Answer. Yes. Correct. Now see guys. What is a underlay and what is a overlay? Need to understand. Yes, Nitish. Nitish, have any doubt?
Sorry, sir, by mistake.
Your audio is not, I'm not able to.
Hello.
Anybody able to hear him?
Hello.
Yes, sir.
Nitish,
He's
your audio
audible.
is not there. Suman, your audio is not there.
Yes.
Hello, sir. Are you able to
Have
hear
you
me?
guys muted or what? Give me a second. Just a second, guys. Just a second. Something. Now you guys can speak. I guess I can hear you now.
Sir, no issue, sir. By mistake, I raised the hand, sir. Sorry.
Okay. No, but it gave me idea that my speaker was off. Your mistake.
Yeah, earlier we were giving answers, so you were not listening. I mean,
Oh, sorry. My mic was sorry, my speaker was turned off. I have not switched to the TV. Now I have switched it. Okay. So now let's start with the first questions. Guys, what is underlay? What is overlay? As per your understanding, correct answer I'm not looking for. I'm looking for participation. Enjoy the session. You will have the learning.
Underlay means direct connection to one node to another. And overlay means above the direct connection, there is a virtual person.
Yes, online guys.
Extra protocols. Any protocol, routing protocols.
Overlay means no, not at all correct.
Underlay physically connected, overlay virtually connected over that underlay.
So see here now, we'll discuss what it is. Don't follow the theoretical part, only follow the content what we are discussing. Consider now vehicle here. This vehicle is running on which terrain? You drive car on sea. Correct? It is land-based vehicle. So you cannot drive vehicle on which terrain? Water. Can you drive your car on water? No, right? So you have limitations there. But if you want to go from one location to another location, car you want to take with you because you want to drive car. So how you will be going from one location to the another location? Then you have to put your car into something and you have to use different transport, which will be your transport for the transport which you are using. Getting it? Your transport will be a carrier or it is a package for another transport, which will take you from one place to another. Means somebody else will be taking you from one place to another. It means what is your carrier? Carrier is here ferry. Correct. Similar way, assume now your packet is IP version 6. Consider this. So far we are using IP version 4. Now your packet is IP version 6 packet. How it packet can go over IP version 4 network over the internet and reach to the IP version 6 network which you are using in your another branch. There is a limitations. You cannot have the direct communication. So in what conditions you will be encapsulating things. Now what is the encapsulation means?
Wrapping up of packets.
Wrapping up something extra. Correct? Encapsulation means you will be wrap something on top of your existing datagram, not only on your data, over the datagram. Datagram means PDU what you are using. So if it is you are doing encapsulation for your layer 3 header, so whole IP packet will be wrapped with another header. So your identity will be what? Let's say you are having a book. This is your book. And this book is regarding, let's say, CCNP. And somebody have wrapped this book and apply the label that this book is of CCIE. What is your identity now? What is inside? CCNP, no? When you will come to know that inside there is a CCNP book, not a CCIE book. After unwrapping it, right? So here you will feel cheated. Let's change the example. Otherwise, you will think this example is not suiting it up. So we'll say, now you are having CCIE book, which is in English. But this book and its label are in English. But this book currently in a place where English is not a main, second, or third language. So very less people know English. So those who know it, they have a wrapper around this. And in local language, they have informed that this book is going for which person from which location. So now this is CCIE book, but this is in, let's say, any other language, let's say Spanish. Now this is a Spanish words. So what you did, you wrap over extra information, which will now understood by many local people. So now anybody can forward this information from one place to another. And here you have written from and to information, like from whom it is came and where it is going. Now, can you route this book in your local area? Yes?
Yes, sir.
Now, if you don't know anything and that book, like that parcel is come to you and you don't understand language, will you able to do anything with that packet? No, right? The similar way, what we did, wrapped something over it. So we'll be going to wrap some extra information over your datagram. So you will be having same data, but outer layer is having different identity. So nobody able to understand what is going inside. Local people understand Spanish, so they will switch packet from one place to another place, and that packet will go to the appropriate destination. Correct? Destination people do understand both the language, English and Spanish. They will open the wrapper and they will see, oh, it's English book. So that's what I've ordered. And they will prepare for a CCA exam. Correct? But these limitations, what you will be going to overcome with, this is with the mechanism called encapsulation. Wrapping, in technical terms, we will call it what? Encapsulation. Now consider here a datagram. Usually what information we have in your IP packet. I'm not going to discuss how your data is converted into the packet now. Segment to packet, everybody know, right? So we will be just discussing here what you're having. Source IP, destination IP, protocol number, anything else? Let's say TTL value and all other parameters. We don't need to worry what all parameters are there. Only required source and destination IP. And this is your IP version 4. So protocol type also we require. So let's say this is IP version 6 packet what we are having. And your existing network is IP version 4. So it will not able to follow this packet. So we will be going to form a tunnel by encapsulating your IP version 6 header over IP version 4. So your identity of your IP version 6 packet is actually IP version 4 in outer layer. So wrapper is IP version 4, but inside is who understand IP version 6. Branch to branch, they understand IP version 6 because they have built their infrastructure on IP version 6. But your ISP network, which will called here onward underlay network, because who will be going to carry your packet from one to other? Underlay network. Let's first understand why it called
ISP.
ISP. Yes, correct. But how and why we called it underlay network? Very from basic we'll understand. Let's go to your internet here. Have you guys visited this before? What is this? Submarine?
Cables.
Cables means another term. Can we call it a internet? It
Yes,
is
sir.
connecting you to one country to another country, one continent to another continent, right? These cables are laid under the sea. It's a physical connectivity. So when somebody asks you how internet come to us, people are saying it coming from the satellite tower. Yes, Elon Musk have implemented it. Starlink can do this, but so far India, we don't have the same technology yet. Correct? So this implementation is currently what we are having. It's a physical connectivity, right? Now understand here. At your shore, you are having this connection. Who will be going to distribute to you? How you will be going to access this? Connectivity is there. Having connectivity means you are not able to use it. You need to have the particular mechanism to connect. Correct? Now understand the infrastructure. Who manage all number resources? IANA. IANA have divided your whole world in 5 regions. Something like APNIC. We are fall under Asia Pacific, and other 4 are there. Asia, Africa, then some others. I'm not recalling the names, but there are 4 or more. So total 5 are there. We fall under APNIC. So I'll just write 1, 2, 3, 4, 5. So we are fall under APNIC. Now under your APNIC will be having tier 1 ISP, tier 2 ISP, and tier 3 ISP. National Internet Registry, state internet registry, and then we come ISP, and then your end user will come. So this hierarchy will be here: national level, state level, and then local hierarchy. Then here your end users will become. So you are actually going from one ISP to another ISP, so to have the communication over the internet. Correct? So all this infrastructure is very large. So currently it is running with IP version 4. And now when you will be going past this information, so internet come to us what? It's physically it is connecting. When you are having internet connectivity here, and let's say you want to increase the range. Yes, you can use a tower to transmit this data at certain frequency. You will be using bandwidth frequency, and at certain distance you will be able to amplify it wirelessly. Then your receivers will be receiving it, your devices. Correct? Then how satellite work, how this work, we will not go into technicalities right now. We need to just understand how the internet is coming to us. So when we say it's underlay, why it is called underlay? Because this laid infrastructure, what we saw, which will be going to carry your packet from one place to another place. So on top of this, your outside identity will be, this is for example, your outside identity will be what? IP version 4. And let's say inside what we took? Inside we took IP version. Let's take this one. So inside you are having IP version 6. So adding your extra header top of this is called encapsulation. To do this in networking, we'll be using GRE, generic encapsulation routing. So it is only encapsulating, means it is having only mechanism of adding extra header on top of your datagram. So GRE do not provide security. Correct? It is only building what? Tunnel. Now, on top of this, we'll be having, you can establish a tunnel now. To secure this, we'll be using IPsec. Now IPsec again will be going to implement it in different way. There are tunnel modes and there are phases, which slightly I'll discuss, not too much details I'll be going to cover, because that is not our concern. We'll be not going to build any tunnels here. Tunnel is already in your SD-WAN, VPN is already configured. You only need to use it. Use the name VPN 0, done. Your VPN will establish. Not a single configuration you have to do for VPN. Okay. SD-WAN automation is already done. Management is done. Analytic is done. Your SNMP is done. SNTP is done. Your HTTP is done. Everything is already done. Means already pre-configured. It will come with. You only have to use it. Where? At graphical level, at very application layer. We understood the architecture, application layer, control layer, and infrastructure layer. Correct? So now you have established a tunnel. Now inside this tunnel, your data is going, but it is not secured. It is only your packet is going. It is a normal packet. In your packet, your datagram, you are holding IP version 6 packet. So your payload is IP version 6, but your packet is going as other packet is going, normal packet. Correct? Correct. It's like you're having a container. Inside that container, you're holding such a valuable things which openly you cannot take it out. Let's say sandal. Correct? Now you have wrapped it into something else, but you can't stop the smell. Correct? Means it is still vulnerable. Means it is still people can identify. So to provide more security over your data, we'll be using, we need a lock on a packet. Yes, we need a lock on a packet. So lock will be provided with the IPsec. What is IP and what sec? It is a IP, Internet Protocol Security. It is inbuilt in your IP version 6. But here we'll be using IPsec over your IP version 4 tunnel what you have established. Tunnel can be 6 to 4, 4 to 6. IP version 4 to 6, 6 to 4. Both tunnel we can do. In your advanced routing, we always do this practical. 6 to 4 and 4 to 6 tunnel we do. But here we don't have requirements, so we'll skip this part. How IPsec will be going to provide authority, authenticity, availability, means CIA, right, to your data. In your security, now we need to discuss couple of things here. Let me bring couple of things here so you can follow. Now you understood tunnel is there, empty blank tunnel is there. Normal packets are going, correct? Tunnel is something which is a virtual. We can only understand it's like a virtual, but actually your normal packet is only going. Do you think tunnel is something else where in thin air it is forming a tunnel? Existing network only will be going to carry your packet, but with a different identity. Means technically you are not visible, but it's not you're secured. You are only not visible. Means I cannot read and take decision based on internal information. I'm taking decision based on the outer layer information. Internal information till it is unsecured. Correct. So next. Now sizes, MTU, all this thing will be skipping it out. Okay. If anybody are interested, you can let me know so we can discuss. See here. This is how your encapsulated packet will look. This is whole carrier packet, and inside you will be having what? Unsupported packet. Correct? Yes, Nitish. Any doubts?
Sir, where it will be done, sir? This packets locking down.
Sorry, come again.
This packet locking you were telling, no, sir, IPsec tunnel. Where it will be locked? Is it a manual thing or a automated thing, sir?
In SD-WAN automatic, but usually it is a manual thing. You will be configuring tunnel once, and then
Okay.
later it will be encrypting, decrypting automatically. Initially, you have to configure it manually.
Okay.
You also can configure it with automation,
Okay.
but that is again part of your traditional network. How many devices you will configure? But remote site, I need to go and understand over SDN only, right?
Yes, sir.
Yes. And another things, this will help you. This is your normal. This is your user data. And this is your original packet. Now this original packet will be what? Act as a payload. Then you will be having new, this is a normal structure. Your packet will go with the frame, and it will go like it will be adding header trailer information in a frame, and then it will be going. Correct. But when we encapsulate it, see what we did. You will be having extra header get added. If you use GRE, it will be adding 24 bytes of header, 20 bytes of new IP address, 4. So 20 bytes of header, IP header will be added, and 4 bytes of GRE information. GRE flags will be there.
Okay.
Okay. So this is what you will be going to do when you will be encapsulating. Now, if you will be adding security, see how the security will be get added. Now we'll remove this. Okay. Now try to understand this in security. Now here security means we are not only talking about our network security. We are talking about general security, cyber security, network security. Do not treat it separate, a part of one only. Only aspect is you are dealing with the network and network devices, and other aspect will be your software base. Okay. But any security, if you consider, this will be the things which will be going to pay attention on. So if you say CIA, right? C stand for confidentiality, integrity, and availability. Let's understand what all these terms. So let me just get the definition which you can easily follow. Now, try to read with me. Confidentially means a principle that will ensure the only authorized user can access this information. This is visible, right? Upon. It's fine now. See, confidentially means what? Only authorized users should access the data. If information is confidential, you are expecting it should deliver to the correct person only. Correct? How you will ensure this? over the untrusted network, if you want to send any data, how you will ensure this? You will encrypt your data, text into ciphertext, readable data into unreadable format. So you need to understand what is encryption, decryption. So you'll be going to do what? Encrypt the data. So it will be protect, right? So it will prevent unauthorized user to access this data. So confidentially will be going to take care what? Encryption is the mechanism to achieve the confidentiality. Correct? Now integrity. Can you tell me what is the integrity? Not tempered means correct. When your data is on transit, see, data is having 3 states. Data at rest, data in transit, data in process. 3 states. When your data is on transit, while your data is on transit, if somebody have tempered it, changed or switched, mimic, there are so many ways you can do so many things with the packets. Force the packet, mimic the packet, manipulate the packet, replace the packet. You are having so many tools to do so, but see, integrity is what? The principle that will be ensure that data is accurate. What I have sent you, you must receive the same thing. How you will verify this information? I'll show you one small practical on this right now. But how you will verify, how you can be sure that the data what you have received, it is coming from the correct source. I have sent, you have received, but in between nobody have tempered it. Like you have ordered something from Amazon, right? Sender have sent a full packet, labels, seals. You received a packet with broken seal. Means nobody tempered it, right? Means somebody, means how you can be sure? Because it's a labeled one. The temp, like those labels, seals will inform you. And then you can reject it. Similar way, when your sender is sending some data, sender will be going to use something, some mechanism as an identity of your data, which is called, they will be using hash mechanism, which is called hashing algorithm they will be using, which is irreversible. Now see what? You will be going to send a data. Your sender is sending what? Data. And sender will be going to calculate one hash value, which is called digest, modulus, hash key, different names. But what it is? Nothing but it is just a identity with respect to algorithm. One algorithm which is called hash algorithm, which will generate a fixed number size, a fixed bit size, whatever your input may be, 1 KB or 10 GB, output will be fixed. So in mathematical term, if you want to understand, it is a term, like if it is a function which takes some input from user as a data. It will be adding some key to do calculation. This function will be going to process mechanically. Now what it do? It will be doing shifting, block shifting, cipher shifting. Then they will be doing permutation combinations. In short, they will be changing the position of your data from one place to another place logically. Mathematically, they will be switching this position, so your data will be unreadable. And they will be generating one fixed key. And that key will be only fixed, and that you cannot go back to the same key. So whatever is output, this output is a fixed length. Fixed length output. And you cannot go back. It's not reversible. Non-reversible. So you cannot go back from that key to data. Then what is the use of this? If you can't go back, then why you are doing hashing? It is an encryption only, but it is an irreversible encryption. Encryption are having 2 types. Symmetric, asymmetric. Under that, we are having this. One is a bidirectional encryption, decryption. This is one-way function. Only encryption, no decryption. So what is the use of this? See here what it will be using it as. When you will be sending any data, you will be going to generate one key. Now over untrusted network, you will be going to send the data. Now your receiver will be going to what? Receive the data. What receiver is receiving? See here, receiver will be going to receive sender's data. Yes. Ajay sir will be on second floor, my room. So whatever sender's data and the hash key, modulus, digest, whatever sender have sent, you have received it, but you will not accept it until and unless you verify it. So what you will do? You will say, yes, you have sent me the correct information, but let me check. So what you will do? You will calculate your own hash value. And this hash value should match. If these two values are matching, because they are generating from same data, mathematical function 2 + 2, 4 for me, same for you also, right? So it should match, right? So same algorithm will check. If these two are matching, the user will be going to accept the data. Otherwise, it will be going to discard the data. This is what integrity means. So to verify this, you will be going to use checksum. So what we discussed, this is called checksum. Today, I'm going to show you the example for checksum. But in SD-WAN, we'll be going to use digital signature. And how digital signature work, we'll discuss in next session. Today, we'll understand the fundamentals. Digital signature in next session. Clear? Any doubts so far? Online, guys? Anthony, Reza, Dachina.
No, sir.
All good?
Yes, sir.
Okay. Now, next thing then. Lastly, availability. What is the meaning of availability? It ensures that authorized person can access information and resources whenever they want. Let me give you example. You are having a Wi-Fi. You mean to connect to the wireless router. But that router is not allow you to connect to the device, whether password is correct, everything is correct. But now router is not able to serve you a service as a wireless connectivity. Why? Because there is a person called hacker sending the authentication packet on your router. So router is busy in responding those packet to reject it. Even though you will be rejecting it, so you will be deny the service what you supposed to do, wireless connectivity, but you are busy for what reason? Denying the packet which you don't request, which you don't want to accept it. So the request which you don't want to accept, that is too much. The number of requests are so much. So the service what you need to serve, you are unable to serve it. This attack called denial of service attack, DOS attack. DOS, denial of service. And if this attack is happening from multiple locations, so it's called DDoS attack. Distributed denial of service attack. Correct? So availability is what? If you want to accept, like if you want to access any data at 2 p.m., you should be able to. 2 a.m. in the morning should be. So availability should be there. So this will fall under your uptime, redundancy, disaster recovery, everything will be covered in your SD-WAN. So what we need to understand? Only fundamentals for now. So only you can follow, right? So let's go forward now. So we'll touch to the topic called cryptography. But to understand your cryptography, you guys need to have a little bit patience. Because not many people will like the mathematical approach, but cryptography is more toward the mathematical part, but a fun way. If you understand it, you will like it. We don't need to do any mathematical calculation. Neither nobody do only the people who develop it, they only need to understand it. We only want to use it. Do everybody of one of us, like any one of us, know how to build a car? No, right? But how to drive it? We know it, right? So we have to focus on the application part, not the development or implementation part. So try to follow with me. Cryptography will be going to understand in 3 ways. It is categorized in a 3-way. Everything is having a different meaning and need. That's why these categories are here. First, you will be going to understand symmetric encryption. What is the symmetric encryption? Usually we discuss whenever somebody asks what is the encryption, people used to say it is having 2 types, symmetric encryption and asymmetric encryption. Why we left him alone? Hashing is also part of cryptography, right? So encryption is having 2 types, 3 types: symmetric encryption, asymmetric encryption, and hashing function. We will call function. It is doing the encryption only, but it is irreversible. So we can't say encryption. It's a function which will generate a fixed value. Correct? So symmetric encryption will be going to use your public key, single key for encryption and decryption purpose. Sender will use the same key to encrypt the data, and receiver will be using the same key to decrypt the data. Now in between, it's your responsibility to take care of public key. If that key is available to anybody, anybody can access your data. Yes. These practicals I'll be going to show you today. Let me first start with hashing. I'll show you the practical, then we'll go for theory. Then might be you will feel fresh. Okay, so let me take you guys to the practical part first. We understood what? In hash function, we'll be generating what? Fixed size key. And this key we called what? Digest, modulus, or hashing key or hash value. So let's just call modulus or key. Let's do practically understand this. Have anybody installed any Linux system? Linux system? Kali or Ubuntu or anything? Okay, no problem. See here.
Sir, Ubuntu I have installed.
Good. Now see, you can relate then. Okay, see here. We are having parrot. Now on Linux terminal, if you want to print anything, Linux or Windows, both will go with command echo. In Windows also, if you type the same command, it will print whatever you will be passing, it will print on your console. So let's say I want to print network security. It will print the same. But now I don't want to print the normal message. I want to pass this input to the function, which is a hashing function. And that function should give me the fixed size output. So I'll be using MD5 sum. Okay, it will give you sum. And it generated one number. It is a 128-bit number and it is a fixed in size. How we can verify? What is the input we have given? Network security. Let me pass 1 character. What is the size of key? 128. Similar way, if you, even though you pass 4 GB, 10 GB of information, till it will generate 128-bit key only. That is the beauty. And at some extent, at some extent, it will be problem. We'll not discuss this, but it is a problem. Now, how we can verify this is a fixed 128-bit number only? Let's copy this. And to this, 1 hexa bit is equal to 4 binary bits. So I'll group 4 digits here. And you guys need to tell me how many bits we will be having here. So tell me now. 1 and here second block of 4. Now in one block, if you considered, what we are having?
16 bits each.
16 bit is 16 fours are
64.
64 plus 64.
128.
So this is fixed 128-bit key, right? Yes.
Yes.
Now, if you have installed any operating system, let's say, let's go online and check whether Kali install you can do or not. If I have internet here. Okay. So this is Kali installation. If I go to the operating system here, the size of operating system is 4 GB. And here, can you see some? We use MD5. But along with MD5, what option we are having? Secured hashing algorithm, SHA. Other are also there, but this is what we will be using. SHA will be preferring. MD5 we don't prefer. So here, they are using secured hashing algorithm 256-bit key. So this key will be of how many bits? 256 bit. How to count? We just understood. Now, what is the purpose of this key? See, who developed this operating system? Kali organization, kali.org. You will be downloading from very safe place called torrent. Correct. So how you can verify what they have give you and what you have download are the same thing. So you will be going to calculate your downloaded file for this algorithm. So this key and your calculated key should be match. They should match. If they are not matching, then the information what you have downloaded, it is tempered, not corrupted, tempered. Yes, you should not use particular information. And same way you will be using pre-shared keys or certification or this encryption for CIA. Not American intelligence we are talking about. Confidentiality, integrity, and availability. Okay. So let's go back. Online guys are there? How many of you are sleeping?
Available, sir.
Yes, sir.
Okay. Not boring, right? Interesting. So what? See. Now we understood hashing with practical. Correct? Now let's go for your symmetric and asymmetric encryption. Symmetric means you will be using same key to encrypt and you will be using same key to decrypt. I have one infographic created on my SD-WAN here. Understand here. Encryption is what? A process of transforming human readable format into ciphertext. Correct? So you are having plain text. You will use some key. It will use some mechanism and it will generate ciphertext. Correct? Now, what is this key? What is this mechanism? We don't need to worry about it. If you are doing cybersecurity or network security, or you're attending advanced routing, then we can discuss much more. Here, you only need to know how to use it. Correct? Now, decryption. What is the decryption? A reverse process of ciphertext to plain text. Decryption is what? You are having a ciphertext, you use the same key. Now this key you are using, which is the same key. Same key for encryption, same key for decryption. So this encryption method we'll call what? Symmetric encryption. Correct? Where same key will be used for encryption and decryption. Then let's understand. I have done it or not here. And your asymmetric key will be using two keys to encrypt your data. What is that? Public key and private key. Now, how public private key work? Practically, I'll be showing you on your router. Consider you're having a sender. And you are expecting to connect with the receiver. Sender want to send some data. So sender how encrypt your data with key. Now there is a mathematical relation between your public and private key. So this key, what we are talking about, call it like public key and private key. They are having a mathematical relationship. If you use one key to lock, you can use another key to unlock. Correct? But the key what you will be sharing, this is public key. And the key what you will be having, that is private key. Private key you don't want to share with anybody. That's why it's called private, right? And the public key you're supposed to be sharing everybody. No, only to the authorized person. So public means it's not available to public. Public key means between two parties, they can share. Correct? Now, this is clear. So, sender will be having its own private key stored on its device. Receiver is having receiver's private key. So receiver is in, let's say, orange. So he's having his private key here. And receiver is having public key of sender. So sender's T key we are having. So whenever you will be sending any information here, let's say in encrypted data, whenever your data comes here, receiver will decrypt this data with the public key. Correct? And then they will have the communication, encryption and decryption. So one will be using one key to encrypt, other will be using another key to decrypt. This is two-way function you'll be using. What all algorithms are there? How they function? We can go into details, but see, a small information we'll discuss. Public key, you have used what? RSA. It's a name of scientist. Some Rishi, some. Not recall. 3 scientists are there. 3 idiots. Then, those names are hard. I'm not able to recall it. Then asymmetric, you are using public and private key. So to have public key and private key, again, you are having 2 categories. How you will be going to encrypt your data? Block by block or stream base. If you're doing block by block, means fixed size encryption. This is called block cipher. Under this, you will be using digital encryption standard, advanced encryption standard, triple DS. So this you will be using. Or you can do streamline. Then you'll be having RC4, TKIP. This we don't use, so we don't need to worry. So in network, which all are you guys are familiar? DS, triple DS, AES. Correct? And this is what we need to understand for your SD-WAN. Now let's go to the practical portion and we can wind up then. So let me take you guys to VMware. Okay, so see here, guys. I'm connecting to my router. This is my laptop. From my laptop, my physical laptop, I'll be going to take access of this router. Usually we have used SSH connection, secured shell connection, to get the console of your device. Which key you will be generating? RSA. And RSA is symmetric key or asymmetric key? Symmetric key, right? Now I'll be showing you asymmetric key you can generate to get the SSH action over RSA. Means public private key, how to generate and authorize with putty. First, get into device. Let this device boot up. Okay, it's already boot up. So nice. Now, configure it, interface gig 0/0, IP address 192.168. Now, you might be asking what IP should I give here? So to check which IP I'm giving, we need to understand which interface I am using to connect to my system here. So it will be VM8 because this is my EVNG management cloud I'm using here. So this will be having 80.0 network. So I'm using IP 80.10. Understood from where this IP came? This is coming from my adapters. Verify the connectivity from my normal CMD, Windows CMD. I'll be going to check the connectivity. If connectivity is done, means we are good to go. And we are having the response, so we are good to go. Now, normally we connect to the putty. So let me first configure SSH here. Otherwise, what you will verify? Say username is what? Admin. Privilege 15. Password is CCIE. Okay. Hostname is already changed, so we can directly say IP, domain, name, CCIE.com security. Now we can say crypto key generate via RSA with modulus 2048. Done. Line VTY 0,4 login local transport input all. Done. Now verify here what it is asking. I'm going to connect to device on 192.168.80.10. And as soon as I ask what it is saying, hey, can you please add that key here? And this key goes with what? RSA and SHA. What is SHA? Secure hashing algorithm. Now tell me, you are using symmetric key with hashing function. So the fingerprint, what you will be going to see, this fingerprint is RSA over hashing function. Correct? If you accept it, you will be able to log in into the system. So we have used what? Admin CCIE. Now we are inside the router. Password is what? CCIE.
Username is Ashmin. AS.
Ashmin.
Spelling mistake.
Spelling mistake. Typo error. Admin changed his name. He didn't tell. Duplicate this session here and remove this. Ashmin.
Only AS, not H.
Okay. Let me check the name of Ashmin. Ah. Now you're on router. And here is your interface configured. Previously, I configured the same IP on another interface, so it is down. So no problem. Okay. I'm closing this. No, I need it. First, I need to configure, no? So let me show what I have to do. Now, first I'll show you the configuration part. Let me first get the keys and all. So here, public authentication, then I'll go to here, type putty, and you will get putty gen. Gen for generation. Generate, generation, not generation. Okay. What it is asking here? Generate public private key. So you are generating your public private key. If you see yes, over RSA with 2048, the key will be using, and just say generate. It will not move forward. Why? We already discussed, right? Hashing function work how? Something you need to give as an input, then it will use its own key. Key is already given, 2048 bits key you will be using. But input, what input you are giving? Here input is mouse movement, mouse location. As soon as I move my mouse, that will be input to the function and it will generate randomly generated key here. See here. If we stop, it will stop. Huh? This is you are generating public and private key. Mathematical function is you are using RSA, yes. Symmetric key with mathematical calculation. With the base on that, can you generate another key?
So we can do that.
That is what I'm doing. So, see, your key will be getting generated and key is ready. Can you see the key? Now let's save this public key and private key. So let's first save the public key with the name of at this desktop Python test April automation. So I'll remove this files. and we'll call it like public key, and we'll save private key. We'll say, do you really want to save it? Because it's risky. You also can easily hack my device if you just take screenshot of this and use some tool, so you can easily get access of my device. You know, this is possible. I'm not inviting you, don't worry, I'll be going to delete it. So at my folder right now, what I'm having? Public and private key. Let's close this, we don't need it. Go to the folder. The folder will be somewhere here. Python test. Where is it? Here it is. Under my Python, April, anyway, this is what we stored, right? Now open this keys. This is your which key? Private key. And we also need public key. Done. Now which key I want to share with my router? So my Windows system without password will log in into the router. Currently we are using what? Password to log in into it, right? Later I'll remove the user only. See here, I'll be going to use public key. This is what? Public key. Copy this public key and paste it into your router. Not directly, follow some steps. Then you can do. So I'll just turn it off because we are already having console open here. So we don't need this connection now. On your router, we have to type IP SSH public key chain. Now we will be entered into public SSH config. Here, give question mark. You will be having what? Username. What username you have to use while you're logging? So username is what? Let's call SD-WAN. Okay. Now you will be entered into user public key SSH configuration mode. Now here you will be finding something as a data. Key string you have to pass. So key string. Enter. You will be entered into which mode? Data. Now what your router looking for? Data. Do we have data copied? Yes. Pass the data here. Now your router is having data. Correct? Exit, exit, exit. Write this information. Do show run. Can you see here? We are having a user here, right? Where is the user? Here is the user. Admin and admin, both are we are having. We'll remove both. Let's copy both. We'll say Tata goodbye to them. And if you come down, you'll be able to see one more information here. IP SSH public key we are having. So public private key will be going to connect. There are previously one key I've stored, which is with Windows 10, like W10. Currently, we are having one more, which is SD-WAN. So we'll be using SD-WAN to log in into your system. So paste. This user say no. Do we have any user now? No, either admin, neither. What happened here? One, yes. Okay. Do show run section user. We don't have any user now. Only public key is available. Now go back to putty. Now this time don't connect directly. Don't just provide the ID 80.10. It It is 80.10. You will be going to down below SSH authentication credential. What it is asking? Public key. You also can pass certificate, but currently we don't discuss certificate. That we'll discuss in your next session. Currently it is looking for what? This is my local system, right? This is in local laptop. So locally, which key I have to use? Private key, which I have shared public key. So I have to go to the location. What I'm having here? Private key. Select it. And we are connecting to this. Just say open. Window will pop up. Now what I have to pass? Only username, and it should logged in into your system without password, because password already given. No, they will calculate. Oh, this is the correct user. This is the public key, private key. Oh, they are good. As soon as you entered, you are into a router without password. This is how your public private key will work. Understood? Clear? Any doubts here online, guys?
Nope.
So today we have finished your cryptography. 99%. 1% we'll discuss on after understanding SD-WAN. Not whole course. What is SD-WAN? Okay. So next session we'll be going to discuss your certification, controllers, and we'll start with your SD-WAN topics. Understanding what is SD-WAN, how SD-WAN function, what all controller are there, what they do, at which layer of architecture they are functioning, and how certificate will work. Everything we'll discuss. So that's all for today. We can wind up here. So let me stop the recording and